Hello students, today we are going to solve a problem on three-hinged circular arch where supports are at same level. So let's see the problem. So here a question from textbook. A three-hinged circular arch hinged at the springing and crown points has a span of 40 meter and central rise of 8 meter. So it's given here. Okay, a three hinge circular arch. Okay, hinged at springing means it's nothing but the supports over here. Okay, so these are the supports and crown point. Okay, here it is a crown point. Now this particular three hinge arch has a span of 40 meter. Okay, so here is a span of 40 meter. Okay, now it has a central rise of 8 meter. So here central rise as 8 meter. It carries a uniformly distributed load of 20 kilonewton per meter. So here it is given uniformly distributed load over the left half of the span. Okay, so this is left half of the span together with a concentrated load of 100 kilonewton at the right quarter span point. Okay, so right quarter means this is the right side of a span and it's at the quarter. Okay, middle of it. So what we have to do, we have to find the reactions at the supports. So we have to find out the reactions here, and then we need to calculate the normal thrust and shear at a section 10 meter from the left support. Okay, 10 meter from left means from this support at 10 meter we need to find out. Okay, so here this particular x is nothing but it is 10 meter. Okay, this is 10 meter. So coming to the solution of this particular problem, okay, we can see as if you remember our simply supported beam problem. Okay, what are the steps, basic steps to solve any problem? Now this is also like the simply supported beam, you may just assume. So for any similar structure, what are the basic steps to calculate the reactions? Okay, so there are two main equilibrium equations, and that is summation of forces in y direction. Okay, y direction means vertical reactions, vertical forces. Okay, that is 0, and there is other equation, moment of all the forces about any one support. So we can consider moment about support A or support B. So it's up to us which moment we can consider. So let us consider for this particular problem, let us consider moment of all forces about support B. So these are the two basic equations we have to use here. There is also a third equation, that is summation of forces in horizontal direction. But as previously also we have discussed that summation of forces in horizontal direction, there are no horizontal forces acting here actually. So in that case it becomes silent. But yes, because of this loading, okay, because of the vertical loading, this particular arch will try to expand outward. Okay, so to that definitely these horizontal forces, they resist this horizontal thrust, it resists the overall loading on that particular arch, so it helps. So we will be calculating horizontal forces as well. So coming to the first equation, now let us calculate what are the summation of forces in y direction. So what is that? We can see here summation of forces in y direction, that is, let us see that at support A it is VA. Okay, at support A it is VA. Okay, so VA plus VB. Okay, at support B there is a other force VB. Okay, you can see the support A VA and support B VB. Okay, which is equal to, okay, that is equal to just see the load here, that is 20 kilonewton here, and there is a 100 kilonewton load acting. So 20 kilonewton is a UDL. Okay, so 20 into 20, so 20 kilonewton, it is that UDL is in kilonewton per meter. Okay, it is in kilonewton per meter. So when we multiply this kilonewton with this particular span, okay, because this particular load is acting over at this span only. So how we are going to calculate? That is 20 into 20, okay, that is 20 into 20. So that is one load plus there is a 100 kilonewton load, okay. So let us add this. So it makes 20 into 20, 400 plus 100, so it is 500, okay. So our vertical reaction, okay, what is our equation? That is Va plus Vb is equal to 500. Let us name it as equation number 1. Now let us consider moment of all, okay, forces about point B, that is summation of forces about. Now let us go for the equation number, next equation, okay. So let us consider summation of all forces about B, okay. Now just see, when we want to consider, when we are considering moment about all, moment of all forces about this support B, so in this case just see what are the forces available at the left side, okay. Just see what are the forces available at the left side. So we can see that there is a vertical reaction, okay. We can see that vertical reaction is there here. There is a horizontal reaction, there is this UDL, and there is this 100 kilonewton. So there are 1, 2, 3 and 4. But a very important point, that this horizontal force is in the same line of action, okay. So we will neglect it, because moment is nothing but load into perpendicular distance, okay. And in this particular case this is in same line of action, so we cannot consider, there is no perpendicular distance for this particular, because this line of action is same for this. So we will neglect this for this particular equation. Now what are the forces? Now let us assume the sign convention, that is clockwise moment is positive, okay. Let us consider clockwise is positive. So let us write the equation here. What we have now, Va is going clockwise, so Va into perpendicular distance is 40. So let's write Va into 40, okay. Now see the UDL. So UDL is 20 into, it is acting over the span of 20 meter. So 20 into 20, 400, and its CG distance, it will act here, okay. So 20 into 20, that is 400 kilonewton, it will be here. 400 kilonewton into perpendicular distance. So what is the distance here? So if you just see here, how much is the distance till support B, okay. So that is 10 plus 10 plus 10, so 30, okay. So next we will write here for UDL, and it is in anti-clockwise direction, okay. It is in anti-clockwise direction, so we will write minus, again I will write it in detail, 20 into 20, which I have written it as 400 there, okay, that is 400 into CG distance, okay. So CG distance will be, that is 10 plus 10 plus 10, that is 30, okay. 30 meter CG distance into plus the next load, okay, point load. So 100 into 10, and it is also in anti-clockwise direction. So that is, sorry, here it is not plus, it will be minus, okay. So this is minus 100 into 10 is equal to 0, okay. So when we solve this equation, we get Va is equal to 325 kilonewton, okay. We get 325 kilonewton. Now once we get this Va value, substitute this Va in equation number 1, okay. Substitute this Va in this particular equation. So when you substitute here Va equals to 325, then we get Vb as 500 minus 325, okay. So we will get Vb as, when we substitute there, so it will be 500 minus 325 is equal to 175 kilonewton, okay. So here we are done with the reactions, okay. We got two reactions here, okay. So we know what is Va, we know what is Vb. So we got these two things. Now let's find out what is the h. Okay, what is the horizontal reaction? So let's calculate that. So here, to calculate horizontal reaction, now we have to consider moment about point C here, because it's hinge. So moment about point C will be 0. Okay, because of hinge, moment at this point is 0. So by considering moment about this point, okay, and consider any one side. So when we consider moment about this point, consider all the, either you consider right side forces or you consider left side forces. You will get the answer. So it's up to you which part you want to consider. Now let us consider right side portion. Okay, so for writing for considering that, now we are just considering right side portion here. So let us just consider this part only. Okay, just ignore this particular part. Okay, only consider the right part. So here consider moment about point C, and that is 0. Bending moment at hinge is 0. Now what are the forces? VB is there, H is there, and 100 is there. Okay, so only 3 forces. Now VB about point C is in anti-clockwise direction, H is in clockwise direction, and 100 is also in clockwise direction. So similarly, we have to simply write the equation, that is minus VB. How much is the distance for C? So that is, you can see 10 plus 10, 20. Okay, so if VE goes like this, so 10 plus 10, 20. Okay, like this, anti-clockwise. So it is VB into 20 plus H is in clockwise. So H into this rise, particular rise. So what is that rise? H is given as 8 meter. Okay, that value is already given in the problem. So we are going to write H into 8 meter. Okay, and 100 into 10, because 100 is like this clockwise. So both of these are positive. So 100 into 10 is equal to 0. So by this equation, when we substitute value of VB here as a 175, right? Just now we have seen. So VB value we got it as 175 kilonewton, and VA we got it as 325 kilonewton. So when we substitute, we get value of H, and that is 312.5 kilonewton. Okay. So here we got all the answers. We got all the answers for the support reaction. We got all the values. Okay. Now question is to calculate normal thrust and shear at a section 10 meter from the left support. Okay, so we have to actually calculate normal thrust and reaction here, normal thrust and shear at this point. Okay, 10 meter from the left side. That's what our question is. Now what we do, let's consider a D be the point 10 meter from the left support. Okay, so this is the point as shown in figure. For more clarity, let's go to the next page. So here, okay, so this X is nothing but it is 10 meter. Okay, now here for this particular case, let D be the point 10 meter from the left support where the normal thrust and shear are to be find out. Okay, at this point we have to find out. Now from the property of circle, okay, in our previous class we have seen that with the property of circle how to calculate this radius R. Okay, now from the property of circle we have a formula, that is H into 2R minus H is equal to L by 2 into L by 2. What is L? L is a total span. Okay, L by 2 means half of the span. Now in this particular case, H is already given as 8 meter. It's given in the data. So simply substitute value here, 8. Okay, R we have to calculate minus 8, and L by 2 is nothing but it is our total span. So 40 by 2 into 40 by 2. So when we solve this, we get R is equal to 29 meter. Okay, R is equal to 29 meter. Now we have to find out what is slope. Okay, now we want to know what is slope, because for calculating vertical shear for V and N, we need to have a theta also. So we need to know what is theta here. Okay, this theta. So how to calculate? Now if you just extend this, okay, just see this angle. This theta is equal to this theta. Now if you consider this theta, so how you will write? Sine theta is equal to this front edge. Okay, this front edge divided by its hypotenuse. Okay, so what is that front edge? It's nothing but we have the value for that, and that is 10 meter. Okay, and divide by R. So we can write theta is equal to sine inverse of 10 by R, and R is nothing but 29. Just now we have found out. Okay, so with this it can be sine inverse of 10 by 29. So with calculator you can see that theta is equal to 20.17 degree. Okay, so this is the value of theta we get. Now let us find out what is vertical shear at D point. Okay, so to calculate vertical shear at D point, okay, so just see vertical shear, what is there at D point. So what are the forces, okay, at D point? So if you see, you just consider a line at D, okay, and just see what are the forces at left side. Okay, just see this part, what are the forces available here. So you can see there is a force VA and there is a UDL. Okay, these are only two forces. So simply you have to write V is equal to support reaction VA minus that UDL only at 10 meter only. Okay, because our D point is it is a 10 meter. So VA is equal to 325 minus 200. So our answer will be 125 kilonewton. Now coming to the normal thrust. So normal thrust formula is N is equal to V sine theta plus H cos theta. So when we substitute values here, V is nothing but 125. 125 sine angle is 29.17. Okay, and then again 20.17. So V is 125 into sine theta. Okay, sine theta is sine of angle is 20.17 plus H. How much H we got? So H value is 312.5 cos theta, cos of 20.17. Okay, so when we calculate, we get 336.437 kilonewton. Okay, so this is our N, normal thrust. Now let's see what is radial shear. So for this our formula is Q equals to V cos theta minus H sin theta. V cos theta minus H sin theta. So V is nothing but 125 cos of 20.17 minus 312.5 sine of 20.17. So here we get 9.575 kilonewton. Okay, so this is our radial shear, this is our normal thrust. Okay, so for this particular, at this point, okay, at this point, this is our normal thrust what we got. Okay, so that is our normal thrust we got, and Q is our radial shear. Okay, so these are the values we have calculated here. So our final solution is this. Okay, hope you understood this problem. Thank you.